When we want to undistribute the greatest common factor from a polynomial, the greatest common factor isn't always immediately obvious. To find the greatest common factor, or GCF, of polynomials, first factor each expression completely. Then the GCF is the product of the common factors, each raised to the lowest power to which that factor occurs in the factorizations. Let's find the GCF of 18x squared and 24x to the fifth. First, we prime factor 18x squared. As a reminder, we've explicitly written 2 as 2 to the first power. Then prime factor 24x to the fifth. The GCF is the product of the common factors with the lowest exponent on each factor. In this case, the GCF is 6x squared. Now let's factor 18x squared plus 24x to the fifth. We have a common factor of 6x squared that we can undistribute. To find the remaining factor, we divide each term by the 6x squared that was factored out. Notice this is reminiscent of multiplying by a clever 1. Now, 18x squared over 6x squared is 3, and 24x to the fifth over 6x squared equals 4x cubed. Our factorization is complete. Now let's consider a more involved example to factor 51x squared y cubed plus 34x cubed y to the fifth. We first need to find the greatest common factor. We do this by factoring each term. First, we factor 51x squared y cubed. Then we factor 34x cubed y to the fifth. Notice that for convenience, we've included factors of 2 to the 0 and 3 to the 0 to keep our common factors lined up nicely. This also helps in the next step. The greatest common factor is the product of the common factors to the lowest exponent to which that factor occurs. 2 and 3 are not really common factors since they don't occur in both factorizations, but using 0 exponents makes this easy to see. So the greatest common factor is 17x squared y cubed. Now we want to factor out the GCF. The GCF was 17x squared y cubed. Again, finding the remaining factor is found by dividing each term by the GCF. We get 17x squared y cubed times the quantity 3 plus 2x y squared. Once we get better at factoring, we omit writing the middle step in the factoring process.